Now we're going to do some more probability example problems, and this is with a deck of cards. So if you remember, in a deck of cards, we have 52 cards. Right here it talks about we have four suits, spades, clubs, hearts, and diamonds. Each suit contains 13 cards. So just keep that in mind as we go through this. I have found that not understanding the different parts of a deck of cards has been one of the things that has tripped up my students in the past. So, using a standard deck of playing cards, calculate each of the following probabilities for randomly drawing two cards one at a time with replacement. So we're going to put it back. So first we're going to draw an ace, and we have 4 aces out of 52 total cards. And then we have a 10, and we want to draw a 10 second. So again, we've got 4 10s out of 52 cards. And then I'm just going to do the little calculator trick because that's the easiest way to calculate this. So 4 divided by 52 times 4 divided by 52. We get this decimal, but we're going to put it back in fraction form. And so our answer would be 1 out of 169. 2 diamonds. So there are 4 suits. That means we have 13 diamonds. So the probability of drawing a diamond is 13 out of 52. And then we put it back in, so it's still 13 out of 52. So 13 divided by 52 times 13 divided by 52. And again, putting it in fraction form, the probability is 1 out of 16. And then what is the probability of drawing any pair? So a pair is just 2 cards that have the same face value. So they're either a face card or a number card. So we're drawing 2 of the same. So the probability of drawing any card would be 52 out of 52. And then we want to draw the same. And so there's 4 of the same cards. So that would be 4 out of 52. Well, 52 over 52, that's just the same as 1. So our answer would be 4 out of 52. And when we reduce that down, we get 1 out of 13. Now it says calculate each of the following probabilities for drawing 3 cards, one at a time with replacement. So again, we're replacing the cards. So 3 of a kind, same as a pair, only there's 3 of them now, right? So the first card, the probability of drawing any card is 52 out of 52, right? Times 4 out of 52 times 4 out of 52. Whoops. So again, this is the same as 1. When we multiply these together, our probability is 1 out of 169. The probability of drawing 3 kings. So a king, there's 4 of them, and then there's 52 cards. And we're going to do that 3 times. And let's stick that in our calculator over here. 4 out of 52. And this is exactly how I would solve these problems if I was doing the assignment. Oh, and see, we get a funky number because we've got a big number here. So we can just do 4 times 4 times 4. We get 64. And then 52 times 52 times 52. And we get 140,608. Let's see. I know 64 is divisible by 8. Let's see if this other number is. Oh, it is. So 64 divided by 8, I'm going to get 8 over 1757. Or, yeah, there we go. 17576. That's still divisible. Let's see if it's still divisible by 8. Oh, it is. So we get, the probability is 1 out of 2197. So that would be our probability for drawing 3 kings, and that is with replacement. So now it says calculate each of the following probabilities for drawing 2 cards one at a time without replacement. There's our key phrase. So our second draw, it's going to be dependent on the first draw. We're not going to have as many cards the second time. So it's the same situations, just a little bit differently. So in ace first, we have 4 aces in the deck. So 4 out of 52. And then we have 4 10s. We still have 4 10s, but we only have 51 cards. So that changes it a little bit. So 4 out of 52 times 4 out of 51. We're going to put that in fraction form. So our probability is 4 out of 663. The probability of drawing 2 diamonds. So at first we have 13 diamonds out of 52 cards. And then now we're down to 12 diamonds and we're down to 51 cards. So we just stick this in our calculator. Put it back in fraction form, and the probability of drawing 2 diamonds is 1 out of 17. The probability of drawing any pair, so again, the probability of drawing any card is 52 out of 52, and then we're going to be down to 3 of whatever card we drew out of 51, and we can reduce 3 out of 51, and it gives us 1 out of 17. And remember, this is the same as multiplying by 1. Now we're going to draw 3 cards at a time, and this is still without replacement. So 3 of a kind, it's going to be 52 out of 52, because the probability of drawing any card is just 1. Then we're down to 3 out of 51, and then now we're down to 2 out of 50. So we don't really need this first part here. We can just do 3 out of 51. Times 2 out of 50. Put that in fraction form, and the probability of drawing 3 of a kind is 1 out of 425. And then our probability of drawing 3 kings, the first king would be 4 out of 52. Then we have 3 kings out of 51, and then we have 2 kings out of 50. And 4 times 3 times 2 gives us 24. 52 times 51 times 50 gives me 132,600. That can obviously be reduced down. And it's divisible by 24, so our probability is 1 out of 5,525.